Question number 6. A block A of mass 3 kgs is attached to one end of a light inextensible string S1. Another block B of mass 2 kg is attached to the other end of the string S1 and is also attached to one end of another light inextensible string S2. Okay, so since this mass is 3 kg, there's going to be a downward force on A, which is going to be 30 Newton weight. Similarly, there's going to be a downward force on B, which is going to be a 20 Newton weight, since weight is equals to mass times G, mg. Oh, and G is 10. Okay. Next, it says that the other end of S2 is attached to a fixed point O, and the blocks hang in equilibrium below O. Equilibrium means that there's nothing moving in here. Find the tension in S1 and the tension in S2. Okay. So the tension on the string S1 is going to be in the upward direction, since tension always points away from the mass. So we're going to use the formula forward force minus backward force is equals to MA. So we can say the downward force is the forward force. So then the backward force is going to be tension is equals to mass times acceleration, but acceleration is 0. So 30 Newton is going to be the tension on string S1. Now let's take a look at the string S2. On S2, the tension is going to be on this direction, but the weight or the downward force on B is actually 20 newtons and 30 newtons, because there are two masses underneath this string S2. So the downward force is going to be the 50 Newton weight, and the upward force is going to be tension. And since there's no acceleration, this body is at rest. So forward force is equals to backward force. So the tension in string S2 is 50 Newton. That's the answer for part 1, 30 Newton and 50 Newton. Next is string S2 breaks and the particle fall. The A resistance on A is 1.6. So there's another back, since the object is falling. So there's A resistance on A, which is another backward force, which would be 1.6 newtons. And A resistance on B is a backward force in this direction, which is 4 Newton. Find the acceleration of the particles and the tension in string S1. Okay, so let's look at object A. At A, there's a forward force, which is the downward force 30 newtons, minus the two backward forces, the tension in the string and the A resistance 1.6. Forward force minus backward force is equals to MA, so is equals to 3A. Okay. This gives us 28.4 minus T is equals to 3A, and let's call this equation number 1. And at B, forward force is 20 minus backward force is T plus 4 is equals to MA, so 2 times A. Okay, there's a mistake that I've made at B. Actually, the tension is downwards. Hold on, let's fix that. So since there's no string 2, so this tension is going to be downwards. Tension is always pointing away from the mass. So if B is the mass, tension is going to be downwards. There is no upward string. There's no string here. So T is here. So the equation is going to be 20 plus T, forward force. There are two forward forces. One of them is the 20 Newton weight. The other one is the tension in downward direction. Minus, there's a 4 Newton backward force is equals to MA. So this is going to be 16 plus T is equals to 2A. We solve these two equations simultaneously and get the value of A and T. So when these two equations are solved simultaneously, we get T is equals to 1.76 newtons and A is equals to 8.88 meters per second square. There's also another way of doing this. That is that since there is no string S2, what we can do is we can consider this to be a single system. So let's say this is a single block and the combined mass of this block is going to be 5 kg. So that means there's going to be a 50 Newton force downwards and there's going to be an upward force combined 4 Newton and 1.6 Newton force. That's going to be 5.6 Newton force. There's no tension in this system because we've combined this. So there's no string now. So it's going to be forward force minus backward force is equals to MA. So mass is going to be 5 kg now, and you should be able to find acceleration from here. So 50 minus 5.6 divided by 5 is equals to 8.88. So we get the acceleration again, same acceleration. Now you can use uh, the equation made on mass A or the equation made on mass B. Use any one of these equations, substitute A in it, and get the value of the tension.